Hello, so today we are going to do this problem, which is part of today's Leetcode daily challenge, minimum time to make rope colorful. So this problem says that so Alice has n balloons, and they are arranged in a rope, so something like this. You can think of it as just a line. And we have a zero indexed strings that represents different colors, right? Or represents colors. So the colors at position I represents the color of the ith balloon. And what Alice wants is she wants the rope to be colorful, which means basically we do not want any two consecutive balloons to have the same color, right? So she asks Bob to remove some balloons from the rope to make it colorful. So basically, whenever there are consecutive balloons, we want to remove all of them except one, right? So that the previous one, the balloon itself, and the one next to it are all different colors. Okay, so in addition to that, we have an array called needed time, where the value at position I of that represents the time in seconds that it takes to remove the ith balloon from the rope, right? We want to remove balloons, and we have the times for each balloon, how much time it takes to remove it. And the goal of the whole problem is to minimize the total time we need to make the rope colorful, right? Because if you have multiple balloons of the same color, like here, you can decide which one to remove, either this one or this one, right? So that's what the problem asks us to do here. So let's take a look at this first example. So we have the needed time here, and we have these. So the ones where we have a problem is these two. And we want to minimize the time to make it colorful, so it makes sense to choose to remove the one with the smallest time, right? And so between these two here, the smallest time is this one, and so which is this one, so we remove it, and we end up like this. Now, no two consecutive balloons have the same color here, right? And so we return the value, which is 3. Okay. Now, if you take a look at the second example, they are already it's already all colorful, right? No consecutive ones have the same color, so we can skip. If we take a look at this one, we have a problem here, we have a problem here, so we choose the smallest one each time. Here, the smallest one is this one, the first one, so we remove it. And then here, the smallest one is the last one, right? So we remove it as well. Yeah, so that's pretty much the idea. In terms of constraint, n, which is the number of colors, can be 10 to the power of 5, right? And needed time is like 10 to the power of 4. Which means basically needed time needs to be equal to the number of non-distinct colors. But what this tells us is that we can't do like an open squared solution. We have to do an open solution or something similar, or Venn log maybe. Yeah, so let's see how we can solve it. Okay, so let's see how we can solve this. So the core idea here is that if you take a look at this group of 2 where there is a problem, or even if you have like 3 or 4, what we want is to always remove the smallest one, right? And regardless of how many we have, right, what do we want to keep? Which balloon we want to keep? So let's say if we have 4 consecutive blue balloons, right? What we want is to keep the largest needed time, because we want to minimize the time. We want to remove all the ones with the smallest time and keep the one with the largest time, right? And remain the other ones, right? And so what this would mean, if we have 4 balloons, it would mean basically the sum of time of all 4 minus the largest time, because that's the one we keep. It's not included in the needed time, and so the max time balloon in those 4 balloons here, right? And basically what I'm doing here is trying to find a generalized way that applies regardless of how many consecutive color buttons we have. So if we have like 4 blue buttons or 5 green buttons, or let's say 9 red buttons, red balloons, this would work. And if we have just 2, like in this blue case, it will work as well. The sum minus the one we want to keep. So this would be the time it takes to make that whatever sequence of colors we have work. Now you may say, okay, can this apply to just one color that is already distinct? Well, yes, because the sum then would be 1 time, so that, let's say it's at position 2, right? So it would be the sum of the time at that position, since it's only 1 button, so it would be the time at that position, minus the max, since it's just 1, the max is itself, so it's minus the time for that one, so it'd be 0. So for the total time that we are calculating, since we would add here to the total time, we would add here this to the total time based on this formula, and we would add 0, and that's exactly what we want. Since we are not removing anything when it's just 1, the total time is 0, right? So this formula will work for all cases that we are going to handle, right? Now the problem becomes, how do we set up the traversal process? When do we add to the total time, right? So the main thing to do here is to think about, so we'll loop through the balloons here. So we'll do 4i in basically the range of colors. So that would be n. And we would have a total time. As long as we have still a run, we need to continue because we want to apply the formula to the entire run of colors, right? So here we want to do something if the colors, the previous one is different than the current one, because now we know that a run of colors is done, right? But otherwise, we just need to keep computing our sum, right? Let's say call sum time is equal to, we want to add the needed time for this position. And then we want to check if this is the max time. If it is, we want to set it. So this would be just taking the max of the max time and the needed time here. Let's just put this here, right? Okay. But if they are different, so here we need to do, of course, bigger than 0. But if they are different, that means we need to record this in our total time. Basically, this would mean, let's say we had a run of, in this case, for example, this would mean we did this and we added to the sum. We did this one and we added to the sum and also did the max for both cases. And now when we are here at this green button, the colors are different. So we need to record the time we need to make these 2 balloons correct. And so to do that, well, what we need to do is just apply this formula, right? Just apply the formula that we had here. So we can just take this formula and grab it here, right? And so what would this be? We want to remove this. So this would be just the total time plus this, right? And here this is the sum. We already have a variable for that, so that would be the sum of time minus the max time. But once we do this, right, remember this is in, for example, in this case that we are at the green, we are starting to attack a new run. Maybe there are multiple green balloons here. Maybe we have another green balloon here, another one here, right? So we need to reset our sum time and max time to take care of the new run, right? So we just reset these to 0 and we reset the sum time to 0s. And then once we exit this if, we will add them and we will check the max, right? So that's basically the idea of this, right? Just traversal and just keep track of it. So pretty straightforward here. In terms of time, this is O(n) and being the size of the number of balloons. So O(n) here. And then in terms of space, we are also just using some variables. So O(1) is space. And that's pretty much the idea here. Now let's check this and make sure it passes test cases. Okay, so let's see the solution here. So pretty much just total time, initialize total time, go through the colors, and then every time add the sum of the current color streak, add the time for that, and then compute the max so far for that colors run. And if we find two that are different, that means we are starting a new color, so we need to add the time for the previous color. And so we add the time, which as we said is the sum time minus the max time, which basically is the time needed to remove all the colors except the maximum ones, all the balloons of the same color except the maximum one, which is what we want since we want to minimize the time. And then we reset for the new color that we have here. And that's pretty much it. And then at the end, this is important that I didn't mention in the overview, which is at the end we want to do this because let's say if the final maybe 3 ones were the same color and we want to add the time to remove the 2, because we want to have a next color to be able to have this condition true, then it will just be stored in some time in max time, and so we need to handle it here. And if the last balloon is just one distinct color, the last streak is just one balloon, then this would be 0 and we'll add nothing, which is correct, right? So that's pretty much it. Now let's run this and let's submit. Okay, so that looks good. Okay, so that passes test cases. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.